Hello again and welcome to the second lesson about the normal distribution for year 13 of the Edexcel A-level maths course. So chapter 3.1 we had a look at the normal distribution, its key characteristics and properties, and how to calculate probabilities based on those key characteristics of the curve. However, to calculate any general probability we need to know how to use a calculator to do that, which is going to be the focus today. Calculating probabilities from the normal distribution using a calculator. Before we get started though, you've probably guessed there are some warm-up questions to get you started and in the right frame of mathematical thinking. So here they are, 4 to try. Try these now, press pause, have a go on these on your own, then press play to double check you've understood how to do these questions and to then self-assess, make sure you've got them correct. Righty-ho, let's have a look then together at question number 1. Question 1, we have a continuous random variable x which is normally distributed such that x follows normal with mean of 30 and a variance, and this is variance of 4. Sketch and label the distribution of x. So again what we need to do, just do this axis. So this is going to be x, the curve goes up and down like so, symmetrically about the mean. So I need to label on the mean here. So the mean is 30 and the standard deviation is 4. So 1, 2, 3 standard deviations is almost all the data. So that could be, for example, 36. And 1, 2, 3 standard deviations on the other side. 6 away from 30 on the other side would be 24. So it's important to note here that the standard deviation is the square root of 4, which is 2. So don't fall for the trap that the standard deviation is 4. It's not in this case. It's always the square root of this value here, which comes second. The first value is a mean. This one's with variance. So to get the standard deviation, we square root of this one. For part B of question 1, we need to sketch the bit of a curve that represents a probability of x being in between 26 and 34. So what we need to do here is label on 26 and also label on 34. I'm going to do an extra line here, which we'll see why in a moment. This is for part C ultimately. But the region which is between 26 and 34, which I'm going to shade, is just going to be this bit here. So all the way from 26 up to 34 is going to be this proportion of the curve. So as I'm calling this in, have a think about what part C asks. Part C asks us to use the knowledge of the normal distribution to actually calculate the probability of x being in between 26 and 34. So what we need to think about here is how 26, 34 relate to 30. Well, 26 and 34, they're both 4 away from the mean. So that's 2, that's 2. This is a gap of 2, and that's a gap of 2. Now 2 is the standard deviation. So standard deviation is 2, and so 26 is 2 standard deviations away on the left, and 34 is 2 standard deviations away from the mean on the right. So one standard deviation would be 28 and 32. 26 and 34 is 2 standard deviations away. And one of the key properties of a normal distribution we found out from the previous lesson is that 95% of all the data will fall within plus or minus 2 standard deviations from the mean. So because 26 to 34 is plus or minus 2 lots of 2 lots of standard deviation from the mean of 30, this must be 95% of all of the probability. So this here, part C, that's 0.95. 95% chance. Let's now have a look at question 2 on this warm-up. Question 2, a throwback really to GCSE this. You've got a table below showing a secondary school's profile of its student numbers. So you've got year groups 7 to 11, numbers of male and female students, and the school wants to survey some of its pupils, maybe for some feedback about school lunches, who knows. Anyway, it's going to plan to take a sample of 100 of its pupils, stratified by year group and sex, whether male or female. Calculate how many female year 10 students should be sampled. Well, what we need to do here is to add up the total frequency. So what's the sum of all the frequencies? So essentially, we're just adding up all these values here. So 62 plus 71 plus 85, all of these added together. So what we can do here is just total these up for male and female. So for male, it's 62 plus 71 plus 85 plus 75 plus 78. That gives a total of 371 male students. And the females, 70 plus 70 plus 87 plus 83 and plus 69. That gives a total of 379. So if we add 371 to 379, we'd get a total there of 750 students. Now, a stratified sample needs to include the same proportion of individuals in its sample as the proportion of those individuals exists in the entire population. So because we want female year 10 students, within the entire school, female year 10s, we had 83 out of 750. So 83 pupils out of 750 in total are year 10 students. We want that same fraction of female year 10s in this sample of 100. So we're now going to multiply that by 100 to get an estimate of how many female year 10s should be sampled. So we just calculate that proportion and round to the nearest whole number of students. So 83 750ths multiplied by 100 gives us a total of, to the nearest student, 11. So 11 year 10 females. Question 3. We've got y equals x squared minus k root x, where k is a constant. First of all, we need to find dy by dx. My suggestion here is to rewrite y in terms of index form. So y equals x squared minus k. Now, the square root of a value is the same as that thing to a power of a half. By writing it in index form, it makes it easier to find the derivative. So dy by dx, all we need to do is bring these powers to the front and knock one off a power. So bring the 2 to the front. 1 less than 2 is 1, so I have 2x to the 1, which is just 2x. Here, the half comes to the front, so now we're going to have a half of k. The power of x now becomes 1 less. A half minus 1 gives us minus a half. So dy by dx is that. The next part of it says, given that y is decreasing when x equals 4, find the set of possible values of k. So if it's decreasing, that means the gradient dy by dx when x equals 4, that has to be negative. That's what it means. So we just plug in when x is 4 into this. And we want this to be negative. A decreasing function is when the gradient is going negative. An increasing function is when the gradient is positive, when it's going up. So here we just plug in when x is 4. into our derivative and see what we get. So dy by dx when x is 4 equals 2 lots of 4 minus a half k times 4 to the minus a half. That has to be less than 0. So now we can neaten this up. So 2 lots of 4 is obviously 8. Now 4 to the minus a half is 1 over the square root of 4. You can just use this on your calculator if you want. You'd find this is a half. Just to show you, 4 to the power of minus a half, that gives us a half. So this becomes minus a half times k times another half, so that's minus a quarter of k. That needs to be less than 0. Rearrange it. A quarter k needs to be greater than 8, so therefore we require k to be bigger than 32. If k is bigger than 32, the function is decreasing. If k is less than 32, we'll have an increasing function. Finally, warm-up question 4. What we've got here is a curve with equation y equals f of x, and it passes through the point 4, 22. We're given that f dash of x, the derivative function, is 3x squared minus 3x minus 7. We need to integrate to find f of x, giving each term in its simplest form. So from here, we can work out that f of x is this integrated. So we need to integrate f dash of x with respect to x. So we increase the power of x by 1 and divide through by the new power. So 3x squared becomes 3x cubed divided by 3, which is just going to be x cubed. Minus 3x will become minus 3x squared over 2. It's going to be minus 3 over 2x squared. Minus 7 will become minus 7x. And then we need to remember to include the constant of integration. And we find the constant of integration by subbing in these points. So sub that when x is 4, f of x is 22. So f of x is 22 when x is 4. So we're just going to plug these values in to work out what c would have to be. That's not what I wanted to do. I wanted a line like this. There we go. So 22, which is f of x, equals 4 cubed minus 3 over 2 lots of 4 squared minus 7 lots of 4 plus c. So now we can generate and work out what c must be. So let's neaten this up slightly. So 22, 4 cubed is 64. That's 16. 3 halves of 16 is 24. So minus 24 minus 28 plus c. That's going to give us 22. 64 take 24 take 28. Let's see what that gives us. 64 take 24 take 28. That is going to give us 12. Therefore, c equals 10. So now we work out what f of x is. So f of x equals x cubed minus 3 over 2x squared minus 7x plus 10. And there we have it. So let's now think about the normal distribution again, and in particular how to calculate any probabilities using the calculator. So how do we do this for the normal distribution? So far we've discovered how to find fixed probabilities using the mean and standard deviation, but this can be extended to find any probability at any distance from the mean by using a calculator. So using the Classwiz, here are the steps in detail. So first of all, yep, you need one of these. So your first step, obviously switch it on is probably your first step, but I'm assuming you could have guessed that. So step 1, we press menu, then 7 to get into distribution mode. So I'll do this as well live. So menu, then we press 7, which is distribution, like you can see here. So press 7 to get into this mode, like so. Then you should have this menu. So next step, on that menu we press 2 to get normal CD. So this menu here, press 2 to get into normal CD. You then have this screen here. So now you've got different scenarios. So you enter the mean next to mu, which you need to scroll down for. So in this case, I'm going to take mu to be 100. Okay, so I'm going to take mu to be 100. I'm going to also fill in the standard deviation, which is 15. Now, upper and lower depends on what question type you've got, and there's 3 main scenarios here. So the first scenario is that you want to find a probability of a type, probability of finding a value lower than some fixed number. So what we do here, we enter A for upper, and then because there's no lower bound, you just put a really low number for the lower boundary. So in my example here, let's imagine I wanted to find the probability of being less than 115. Now I've put the standard deviation as 15, and you should remember from part 1, chapter 3.1, that anything which is less than 1 standard deviation away from the mean is 68% of all the data. So within 1 standard deviation, 68%. So if I type this in now, I'm going to get 84%. There's going to be 34% of that 68 on the right hand side, plus all of the left hand side of the curve. So if I press equals in a moment, I'm going to type in my upper of 115, and my lower, I just type in any small value. I need it to be at least 5 standard deviations away from the mean. So 5 times 15 is 75. I want this lower number to be at least smaller than 25. What I tend to do is just type in minus 9999 for something really small, or plus 99999 for something really big. So this should give us 0.84 if what I've said is correct. And as you say, it's about 0.84. The second scenario is if you want to find the probability of being higher than some value. So let's imagine I wanted to find the probability that my observed variable is, say, 85 or higher. So what I want to do here, for the lower, I type in 85. For the upper, I just type in something which is at least 5 standard deviations more than the mean. So 100 plus 5 lots of 15 would be 175. But again, just type in a massive number. You can't go too far wrong. So again, this should be 0.84 as well, to 2 decimal places. As you see, it is. The final scenario is if you wanted to find a probability which is in between 2 values. You'd enter A for the lower one and B for the upper one. So let's imagine now I wanted to find the probability of it being between 85 and 115. Now remember, the mean is 100, so I'm trying to find the probability that it's plus or minus 1 standard deviation away from the mean. 100 minus 15 for this one, and 100 plus 15 for the upper. And as you know from the standard deviation and the properties of the normal distribution, all the data which is within 1 standard deviation away from the mean should be 68% of the data. So when I press equals now, I'll get a figure of about 0.68, which of course I do. So that just shows you that it works and it's consistent with what we saw in chapter 3.1. But the only difference is now we're not limited to just working out probabilities that are 1 standard deviation, 2 standard deviations, or 3 standard deviations away from the mean. We can work out the probabilities for pretty much any value we need. So let's do this now with some worked examples. Of course, step 4, which was missing, step 4 you press equals to find the actual required probability. So step 4 is there just to finish it off, but you could probably guess pressing equals is what you do on a calculator. But just so the steps are complete, I added that in as well. Let's have a look at some worked examples, and hopefully you'll see this is particularly straightforward actually. So here we've got a continuous random variable x, normally distributed, such that x is normally distributed, mean of 30, a variance of 4. So that variance of 4 means the standard deviation is 2. So we need to find these probabilities. So again, what I'll just do is sketch these out because it can't hurt to. So the first one, I just want to find the probability that it's less than 35. So the mean's 30. Importantly, the standard deviation is a square root of 4, which is 2. And I want to find this region here on the left, so all the way up to 35. So as you can see, it's bounded on the higher end by 35. We want everything up to 35 but no higher, and it's not bounded at the lower end. So for this one, we get the calculator ready. Now, our parameters, we've got a mean of 30, so press mu as 30. The standard deviation isn't 4, it's a square root of that, which is 2, so be sure to type in 2. Here, the upper bound, the bigger number, is 35, so the upper limit is 35, and we don't have a lower limit, so we just fill in a value for the lower, which is as low as you dare go. So I'm just going to type minus 9999. As long as it's at least 5 standard deviations away from the mean on the low side, you're fine. I always in the habit of typing in a massively negative number. So press that in, press equals. We get 0.994 to 3 significant figures. So that's a huge probability. Oops, that's not a very straight line. There we go. This one here, same parameters. What's the chance of it being more than 27? So again, if you want to sketch out the curve, you can do. If you're thinking, do you have to sketch out the curve? Ultimately, no, you don't. But I think it just makes it easier to visualize the question you need to do. So here, I want 27 or higher. So this time, I've got a lower bound of 27, and it's unbounded on the upper limit. So it's all of this area of the curve here, from 27 upwards. So what I'm going to do now is get the calculator, of course. Now this time, I've got a lower bound of 27, and it's not bounded at the upper end. So it's from 27 all the way to infinity, really. Now, of course, as you go towards infinity, the probabilities as you go along get so close to 0, they practically are 0. So just pick a massive value for your upper. I'm going to go for 99999. The parameters are unchanged because it's still 30 for the mean, standard deviation of 2. So press equals, and we get 0.933. And then for C, this is bounded on both sides now. So again, we've got the mean, which is 30. We want to find probability of a value falling in between 31.5 and 25.5. So again, what we're after here is this bit in the middle, which is bounded at the lower end and the upper end now. So what we do here, press AC, now we type in the lower value, 25.5, press equals, the upper one, 31.5, leave the parameters untouched because they're still going to be the same, press equals, we get 0.761. Whoops, that's a bit of a different pen, didn't mean that. 0.761. Moving on to part D and E of question 1, so the parameters are still going to be unchanged. What's the probability of it being greater than 33 or less than 26.2? Well, let's think about this. So again, if we draw it out, we know the mean is 30. The chance of it being more than 33 is essentially this tail bit of a curve at the higher end. The chance of it being less than 26.2, similar idea, I'm looking at this lower end, anything less than 26.2 relates to this tail end of a curve at the left-hand side. So this essentially can be done in one fell swoop. I'm just going to show you how now. So probability that it's more than 33 or less than 26.2, that's essentially all of this curve apart from this middle bit. So it's everything apart from this bit in the middle. So we could do a 1 minus scenario. And this might be easier than working out each tail separately. So sometimes I don't spot the obvious. Thank you to Mr. Yusuf Baker for this method, which is quicker. I just thought, well, his method does make more sense. Let's just use this quicker method, and it gets you there slightly more efficiently. So this bit in the middle is a probability of x being in between 26.2 and 33. You could work out each tail separately and then add them, or what I'm going to do here, I'm going to do 1 minus this bit here. Try it your way if you want, work out each tail separately and add them together. You will see it's the same. So this blue bit, what I can do here is just fill in on the calculator the values. So lower 26.2, upper 33. I get 0.90447. So I do 1 minus 0.90447. And that will give me the required value. So if I store this value in the calculator, go to menu 1, 1 minus that stored answer gives me 0.0955. 0.0955. And finally for question 1, E, probability of observing a value between 23 and 33 and less than 25. Well, here, if we just go back to GCSE for a moment and think about this before diving in, this bit here, between 23 and 33, if I label 23 there and 33 here, that probability on a number line would look like this. And this bit, 25 or less, would be a line starting from 25 but pointing to the lower end because it needs to be less than 25. So where are these two inequalities both satisfied? Well, they're both satisfied only for this region. So the only thing that satisfies both inequalities is when x is between 23 and 25. Don't know, I've done that actually. Yes, it's between these bits here, 23 and 25. So again, if you wanted to sketch this out, you could, or you could just plug in the values straight away and generate the answer. If you want to visualize what's going on though, again, you've got the mean of 30. You're trying to find out the probability being between 23 and 25. You're wanting essentially this region here. So therefore, probability of x being between these two and less than 25 is just this region here in purple. So we get the calculator, type in the boundaries 23 and 25. So we go to menu, option 7, we go to normal CD. Standard deviation was 2 and mean was 30, of course. And then we type in that the lower is 23, upper 25, press equals and equals again. We get here a very tiny value of 5.977 times 10 to the minus 3. So this one's going to be 0.00598. To 3 significant figures. Yeah, 598, 0.00598. Let's now have a look at worked example 2. So, an IQ test is applied to a population of adults. The scores big X are found to be normally distributed with a mean of 100 and standard deviation of 15. So the variance is 15 squared. Adults scoring more than 140 on the test are classified as geniuses. So find the probability of an adult chosen at random achieves genius classification. So for part A, I'm just going to sketch the curve as follows. Okay, so the mean is 100. 140 or higher is genius. Obviously 140 or higher is going to be very rare. So I put 140 here. I'm trying to find this tiny tail, which is the proportion of the population which are geniuses. So for part A, I ask you to work out the probability, oops, I put A already, probability of observing an IQ of 140 or greater. So I just type in these parameters on the calculator and let the calculator do the legwork. So what I've got here, it says I've got the mean is 100. So toggle to the mean, type in 100. The standard deviation is the square root of 15 squared. It's just 15. I need an IQ of at least 140 to be classified as genius. So my lower bound is 140 and my upper bound is unbounded. But I'm pretty sure anyone will have an IQ of 100,000 or less. So just type in a massive number there, which is at least 5 standard deviations above the mean. I'll just go for numbers, lots of 9s. So press equals, and you should be finding a very small probability because obviously very few people are geniuses. So press equals, and we get here this value, which as you can see is particularly small. It's times 10 to the minus 3. So this is going to be 0.00383. So that's about 0.004. That's the same as saying about 4 people in 1,000 would be classified as a genius. So I wouldn't think it should be any higher than that, in fact. So that seems semi-reasonable to me. I'd think maybe it'd be lower, but as long as you've got a low probability, you can think, okay, that sort of makes sense, and it does. Now, part B. Find the probability that at least 3 people are classified as a genius. Now, part B is actually binomial now. So the examiner will often mix different distributions together. So someone's either a genius or they are not. Okay? So this is actually going to be, for part B, a binomial question nested into a normal distribution question. So I'll explain how to set this up. So there's 60 adults taking the test. X is the distribution of IQs. So I'm going to say let big Y be the distribution of number of geniuses observed out of 60 adults. Then we can say that Y would be binomial distributed, 60 adults, and the probability of any one of those adults being a genius is this tiny value here, about 0.00383. So then, the probability of having at least 3 geniuses, so probability that Y is 3 geniuses or more out of 60, that's going to be 1 minus a probability of 2 or fewer geniuses. So now we need to get back into binomial mode. So we go to menu, option 7, press down to get to binomial CD, and press 2 for variable. So now the number of people is 60. The proportion of geniuses, the probability of a genius being observed is 0.00, one too many zeros, 383. And we want to find the probability of 2 or fewer geniuses. So type 2, press equals and equals again. We get 0.9983 and so on. So it's 1 minus 0.9983 and so on. So we're going to press equals, menu option 1, so 1 minus our observed probability, we get 1.63 times 10 to the 3, so it's 0.00163. So that's a very small chance indeed of having 3 or more geniuses out of 60, which you'd expect. To get 1 genius out of 60 to be rare, 3 or more would be very rare. So this is about a 1 in 1,000 chance, which I think is fairly expected. There's going to be not very many groups of 60 adults where 3 or more of them are going to be geniuses. Imagine 1,000 different rooms of 60 adults in. The only room out of 1,000 where that would be true would maybe be an incredibly high-flying think tank or Harvard University Law School, I don't know. But you'd expect this probability to be very low, which it is. So does amount to make sense? Yes, it does. Always be thinking in those terms if possible. So that's enough from me. It's over to you now to try some of these on your own. So if you turn to page 43, exercise 3B, and try questions 1, 3, 4, 7, 8, 9, 10, 11, 12, and beaver away at those as well as you can. If you get stuck, let me know, leave a comment, please like and subscribe. Thank you again for tuning in, and you'll hear from me again very soon. So goodbye for now, and take care of yourselves.